0400 hours, Philippine Sea. A Type 055 guided missile destroyer cuts through dark water at 28 knots, its phased array radar sweeping a 400 nautical mile search arc as it escorts China's newest supercarrier, the Type 003 Fujian, through the Luzon Strait. For 3 decades, Western analysts classified China's carrier program as aspirational, constrained by doctrine gaps, industrial limits, and an aircrew pipeline that simply cannot sustain high-tempo flight operations. That classification no longer applies. According to a May 2026 analysis by the Center for Strategic and International Studies, the People's Liberation Army Navy now operates 3 aircraft carriers in overlapping deployment cycles. The 80,000-ton Fujian joins the Liaoning and the Shandong, initiating what defense researchers formally call China's 3-carrier era. 3 simultaneous carriers at sea marks a structural shift in how power is projected across the Indo-Pacific, and the engineering, logistics, and tactical doctrine behind that shift warrants close examination. The Fujian itself represents years of indigenous construction work. Launched from the Jiangnan shipyard in Shanghai, it carries electromagnetic catapults, a concept previously exclusive to the United States Navy's Gerald R. Ford-class carriers. The Liaoning, converted from a Soviet-era hull, and the Shandong, China's first fully domestic build, operate conventional ski-jump flight decks that restrict the launch weight of carrier aircraft. The Fujian's catapult-equipped flat deck separates it from those predecessors by a measurable operational margin, allowing fully fueled, fully armed aircraft to reach their maximum combat radius from the moment they leave the ship. The deployment of all 3 carriers does not happen spontaneously. The PLAAN implements a strict 3-phase rotation. 1 carrier undergoes scheduled maintenance, 1 conducts workup training with its air wing, and 1 maintains active patrol status in contested waters. This cycle keeps at least 1 carrier operationally available at all times, which mirrors the structural logic the United States Navy applies to sustain forward presence in the Western Pacific. Replicating that logic at this scale represents a doctrinal maturation that analysts at the Naval War College in Newport now track as a primary concern in their Indo-Pacific planning models. The strategic geography driving this expansion centers on 2 concentric arcs. The first island chain runs from the Japanese archipelago through Taiwan and the Philippines down to Borneo, and it has historically served as a containing boundary for Chinese naval operations. The second island chain, anchored by Guam, approximately 1,600 nautical miles from Shanghai, marks the outer boundary of the zone China now actively contests. By deploying carrier strike groups into the Philippine Sea, the PLAN extends combat aircraft reach well beyond what land-based fighters can achieve from the Chinese coastline alone. A J-35 stealth fighter, launched from the Fujian's deck, carries an estimated combat radius of approximately 1,200 kilometers from the ship, pushing the effective strike envelope deep into waters that US and Allied surface forces previously crossed without serious challenge. If you want to stay ahead of critical updates on global naval power shifts, subscribe to our channel now. Let us continue with China's carrier logistics. That geographic ambition creates an immediate logistical problem of considerable scale. A single carrier strike group consumes thousands of tons of fuel and aviation ordnance per week during sustained flight operations, according to open-source military logistics estimates. Maintaining 3 such groups requires a replenishment infrastructure that the PLAN has spent 15 years constructing. The principal solution is the Type 901 Fast Combat Support Ship, a 45,000-ton replenishment vessel capable of transferring fuel, aviation stores, and dry cargo, while both ships maintain speeds of 18 knots. 2 Type 901 hulls are currently in service. Each transfer evolution at sea moves roughly 600 tons of fuel per hour, keeping the strike group's tanks above the threshold required for sustained flight operations. The Type 901 solves the fuel equation at sea, but does not resolve the deeper problem of forward basing. The United States Navy draws on a network of deep-water port facilities stretching from Yokosuka in Japan to Apra Harbor in Guam to Diego Garcia in the Indian Ocean. The PLAN currently lacks equivalent facilities beyond the South China Sea, and that absence constrains how far a carrier strike group can operate before it must return to Chinese territorial waters. A PLAN strike group operating near the second island chain sits roughly 5 to 7 days of steaming from the nearest Chinese naval base, and that transit window represents a period of elevated vulnerability to submarine interdiction along predictable return routes. To address this structural endurance gap, Beijing accelerates construction of the Type 004 carrier at Dalian Shipbuilding Industries. Satellite imagery reviewed by analysts at CSIS in May 2026 shows prefabricated hull blocks already in assembly stages at the Dalian facility. The Type 004 design calls for nuclear propulsion, which would eliminate the fuel constraint entirely and allow sustained operations at distances the current conventional power carriers cannot maintain. A nuclear-powered carrier can remain at sea for 20 years between reactor fuel cycles, with operational endurance limited only by food, aviation ordnance, and aircrew fatigue. That is the capability gap the Fujian's conventional propulsion cannot close, which is precisely why the Type 004 program holds priority funding within the PLAN's shipbuilding budget. The Fujian's engineering introduces a second paradox that deserves direct examination. Its electromagnetic aircraft launch system, known as EMALS, draws power from a medium-voltage direct current integrated power architecture. This design allows the ship's turbines to supply electrical energy to both propulsion and launch operations through a unified distribution network. The theoretical advantage is flexibility. The ship redirects power between propulsion and flight operations depending on tactical demand. In practice, the conventional steam turbine arrangement that drives the Fujian generates less total electrical capacity than the nuclear plant aboard a Gerald R. Ford-class carrier. At high speed, propulsion draws priority, which reduces the power available for launch cycles. During sustained combat operations requiring maximum sortie generation, this constraint becomes operationally relevant. Chinese engineers address this limitation through high-capacity direct current supercapacitor banks integrated into the EMALS power chain. These arrays store electrical energy during periods of low demand and discharge it in precisely timed surges during catapult launch sequences. The result is that individual launch events do not directly stress the ship's generator output, because the stored charge provides the instantaneous power spike the catapult requires. The engineering team at Jiangnan Shipyard draws on research from the Chinese Academy of Sciences to develop capacitor arrays, capable of sustaining launch cycle intervals of approximately 45 seconds per aircraft, which is comparable to the Gerald R. Ford's tested performance. That technical solution transforms what appears to be a fundamental power deficit into a manageable engineering constraint. These 45-second cycles enable a high-frequency sortie generation rate that approaches Western operational standards. For context, the United States Navy's Nimitz-class carriers operate at a sustained rate of approximately 120 sorties per day with a fully trained air wing. The gap is measurable, but not disqualifying from a regional sea control perspective. 80 sorties per day from a carrier operating in the Philippine Sea represents a combat air concentration that no regional force other than the United States currently matches, and the aircraft filling those sortie slots now include the J-35 stealth fighter, which carries an internal weapons bay and a radar cross-section designed to defeat the S-band search radars deployed aboard most regional surface combatants. The KJ-600 airborne early warning aircraft compounds that threat further. Comparable in concept to the American E-2D Advanced Hawkeye, the KJ-600 operates a rotodome radar from a turboprop airframe that the Fujian's catapults can launch fully fueled. It extends the strike group's sensor horizon by 350 kilometers beyond the ship's own radar, creating a detection picture that allows the carrier to position its combat air patrol before threats reach the outer defensive perimeter. The combination of J-35 strike capability and KJ-600 surveillance reach gives the Fujian a tactical package that the Liaoning and Shandong, both limited to ski-jump launch profiles, cannot replicate. The geopolitical weight of that capability projects directly onto the first island chain choke points. The Bashi Channel, the 150-kilometer passage between Taiwan and Luzon, serves as a primary route. Planned surface groups transiting these passages do so under constant surveillance from Japanese P-1 maritime patrol aircraft and US Navy attack submarines operating from Guam and land-based anti-ship missile batteries positioned along the Nansei-Shoto island chain. Japan deploys Type 12 surface-to-ship missiles along those islands with a current range of 200 kilometers and commits under its December 2022 National Security Strategy to extending that range to 1,200 kilometers, a program that analysts at the International Institute for Strategic Studies confirm remains on schedule as of early 2026. The combination of submarine coverage, missile overmatch, and sustained air surveillance creates a detection and strike network that places any planned carrier strike group at risk during choke point transit in the opening hours of a conflict. To reduce that exposure, the plan integrates Type O-52D guided missile destroyers into every carrier escort formation. Each Type O-52D carries 64 vertical launch system cells loaded with a mixture of HHQ-9B long-range surface-to-air missiles, YJ-18 anti-ship cruise missiles, and CY-5 anti-submarine rockets. The Type O-52D's active phased array radar tracks airborne contacts at 200 nautical miles, giving the strike group early warning well before incoming weapons reach their terminal phase. J-15 fighters flying the outer combat air patrol extend the defensive perimeter to 400 kilometers from the carrier, which means any aircraft attempting to approach the Fujian must first penetrate a layered barrier of radar-guided interceptors backed by shipborne surface-to-air coverage. This layered architecture addresses a tactical vulnerability that recent maritime conflicts expose with clear evidence. Analysis of attacks on surface combatants in the Red Sea between 2024 and 2025 demonstrates that low-cost surface drones and anti-ship ballistic missiles represent a more acute threat to large surface ships than traditional air-breathing cruise missiles. A surface drone carrying a shaped charge warhead at $50,000 per unit can disable propulsion systems on a $2 billion frigate in under 90 seconds at close range. And the cost ratio of threat to interceptor is a logistical problem no fleet has fully resolved. The PLAN responds by deploying Type 1130 close-in weapon systems aboard the Fujian, a 30mm Gatling cannon array capable of firing 10,000 rounds per minute to neutralize terminal threats within 3 kilometers of the hull. Electronic warfare jamming suites aboard the Type 055 escorts add a second layer of terminal defense by degrading the GPS and data link signals that guide incoming drone swarms. The broader response from allied navies takes measurable form. The United States regularly deploys multiple carrier strike groups to the Western Pacific on a concurrent basis. Australia accelerates its acquisition of Tomahawk cruise missiles under the AUKUS arrangement, adding a long-range land attack capability to surface combatants that previously lacked it. South Korea, meanwhile, has deprioritized its CVX light carrier program in favor of multi-purpose manned-unmanned command ship platforms. Each of these programs responds directly to the three-carrier deployment's alteration of the regional force balance. The three-carrier deployment is, at its core, a statement of industrial capacity translated into operational hardware. China's shipbuilding output in 2025 exceeds 1,700 vessels across all commercial and naval categories, a figure that substantially outpaces US shipbuilding production for the same year, according to data compiled by Clarkson's research. That industrial base feeds directly into the PLAN's expansion timeline. Whether the Type 004 nuclear carrier reaches operational status by 2030 or 2032 matters less than the structural fact that the construction program is active, funded, and progressing on a traceable schedule, observable in commercially available satellite imagery. The naval lesson that emerges from watching this deployment structure take shape is one that planners in Washington, Tokyo, and Canberra now incorporate into contingency modeling. Carrier-centric sea control is no longer an exclusively Western capability. The logistical, engineering, and doctrinal barriers that once separated the United States Navy's carrier force from all competitors have not disappeared, but the gap has been substantially narrowed. The Fujian's electromagnetic catapults, the Type 901's at-sea replenishment capacity, the J-35's low observable characteristics, and the KJ-600's surveillance reach, collectively constitute a strike package that any regional commander must now place in the threat calculus from the first day of planning. The Philippine Sea, which US carrier commanders crossed without serious contest for 7 decades, now demands a different set of assumptions. 3 carriers are at sea. A 4th is in the frames at Dalian. And the waters between the island chains grow measurably more contested with each deployment cycle the PLAN completes without incident.